Hydrazine is used as a rocket fuel. It contains 87.5% of nitrogen and 12.5% of hydrogen. Determine the empirical formula of the compound. If the molar mass of hydrazine is 32 gram per mole, determine its molecular formula of the compound. So what we can do is we list out the information as usual. So that is nitrogen and hydrogen. Nitrogen 87.5 gram, right? And hydrogen is 12.5 gram. 87.5 gram, and this one is 12.5 gram. So we need to find the number of mole. 87.5 divided by 14, and number of mole for hydrogen is 12.5 mole because it's divided by 1. So 87.5 divided by 14, that will give you the figure of 6.25. 6.25. Now the ratio of N to H is actually 1 to 2 because 6.25 to 12.5 is in the ratio of 1 to 2. So the empirical formula should be NH2. You know why? Because as I can point out to you, this one is 1 part and then this 2 parts. If you don't believe, you can use 12.5 divided by 6.25. You get 2. So if the molar mass of hydrazine is 32 gram per mole, determine its molecular formula of the compound. Now 32 is the actual molar mass. How about this? Can you try to calculate the molar mass here? 14 plus 2 times 1, you only get 16. How do you connect 16 with 32? By multiplying 2. Alright? So because of this, the actual molecular formula for the compound of hydrazine is actually N2H4. N2H4. If you don't believe, you can calculate 2 times 14, 28, 28 plus 4, you get 32. Let's move on with another question. 20. X gram of iron combined with 5.04 gram of oxygen to form an oxide with empirical formula of Fe2O3. Determine the value of X. Alright? So again, we use the same method. Iron is Fe, oxygen is O. The formula is given as Fe2O3. Ratio is 2 to 3. Now, look at this. Oxygen has 5.04 gram. So number of mole is 5.04 divided by 16. And you get 0.315 mole. As for Fe, you know that it has X gram. Number of mole is X over 56. Right? So we need a few information to be transferred to the whiteboard. We need this, this, as well as this and this. Alright? So we go to the whiteboard. So we have Fe, we have O, and then we have 2, 3, ratio of 2, 3. We also have 0.315 mole, and here we have X over 56 because 56 is the molar mass of iron. Now we want to relate all this information together, and we can write X over 56 divided by 0.315 is the same as 2 divided by 3. Okay, this one divided by each other, divided by. Right? So what you have is, here you have 203, and here you have X over 56 times 0.315. Okay, to make things easier for you, I'd like to start a new H 17.64. So x over 17.64 equals to 2 over 3. Okay, let's make this cleaner. 17.64. Alright, so you can find x by using your calculator. 2 over 3 times 17.64. So you get 11.76 gram. This one they are asking for the actual mass of iron. Okay, the actual mass of iron. Alright, so we try another question. A gaseous hydrocarbon Q contains 20% hydrogen. 6 grams of this hydrocarbon occupies a volume of 4.48 dm cubed at STP. 1 mole of gas occupies a volume of 2.4 dm cubed at STP. Determine the empirical formula, molar mass, as well as the molecular formula of Q. Now, this is a similar question that we have done before. Okay, we just have to pay attention to this. We have to be very careful with two separate pieces of information. This one and this one is meant for question B. Okay, the first part you can actually solve it right here. I can solve it right here for you. Hydrocarbon is C something HY. Alright, so carbon would have 80%, so 80 gram. Hydrogen would have 20%, 20 gram. It's mentioned in the question. So find the number of mole. Number of mole for carbon is 80 divided by 16. That will give you, no, 80 divided by 12, not 16. You get 6.67. 20 divided by 1 is just 20. Alright, so 20 divided by 6.67, you get almost 3. So this is ratio of 1 to 3. Ratio of 1 to 3. Because first you find the mass, second you find the mole. The mole is, for this, is actually 80 divided by 12. Find the mole. This one, the number of mole is actually 20 divided by 1. So the ratio of 1:3 tells us that the empirical formula is CH3. Okay. The next piece of information, look at the red brackets. 6 grams of hydrocarbon occupies volume 4.48 at STP. So we need a whiteboard. So 6 grams, you occupy 4.48 dm cubed. And the keyword is STP. Now, you know that the number of mole is mass over molar mass. Number of mole can also be V over 2.4. Can I put this in? Yes, I can. So 4.48 divided by 2.4. That will give you the mole of that will give you 0.2. So can I put 0.2 here? Can I copy towards here? Yes, I can. So can I put this 6 grams here? Yes, I can. So I can find the molar mass of carbon quite easily. So 6 over 0.2, you get 30. Okay, molar mass of not carbon, molar mass of the compound CH3, 30. So back to this. So if I have CH3 and the molar mass is 30, if I calculate here, I have 12 plus 3 times 1. I can only have 15 grams per mole. How do I connect with this? The only way is to have CH3 multiplied by 2, so you get C2H6. Because C2H6, if you find the molar mass, is 2 times 12, 24, plus 6 times 1, 6, you get 30. So we are actually finding the molecular formula for this. So we are finding C2H6. And this is only a empirical formula.